Today's problem, remove duplicates from sorted array. This is available on the 12-week interview preparation kit on Interview Bit. So pause the video, go over there, try the problem, come back, we'll walk through it. This is rated as easy. It's asked at Amazon, Google, Microsoft, Expedia. Okay. Problem description. Well, I guess I should say something about these problems being rated easy. I mean, they're easy if you know the patterns that you should know. Not that you just come in completely unprepared and solve this problem anyway because it's easy. It's not really easy in that way. Okay, problem description, given a sorted array, A. Now again, for Java, we're getting a list here, a sorted list consisting of duplicate elements. That is, some elements may be duplicated, some or none. Your task is to remove all the duplicates, return the length of the sorted array of distinct elements consisting of all distinct elements present in A. Note, you need to update the elements of array A by removing all the duplicates. Okay. Now see this, notice how many dislikes this problem gets. It's pretty unusual. Usually there's just, there might be 291 likes and maybe 11 dislikes. There's a lot to dislike about this problem. The descriptions, it's not, well, anyway, like this, removing all the duplicates. If you remove the duplicates, that's wrong. First of all, my first pass through this was, okay, remove the duplicates and return the number of distinct elements, like this one, input 1, 1, 1, 2. There's two distinct elements, so the output is 2. This one has 3 distinct elements, so we return 3. Well, one problem is if you try to go through the array list and just keep track, the first time you see a number, you keep track of it, and then as you keep seeing it, you remove, 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 remove. It's going to time out. All right, that's the first problem. So then you say, well, okay, I'm not going to remove the elements. What I'm going to do is just keep track of the first time that I see a number, and then as I keep seeing it, just increment the index and skip it and count the number of distinct elements and then just return like 2 or 3 again. Now that also fails. The reason it fails, you have to look all the way down here into the explanation and say, here's the updated array after rearranging. 1, 2, X. That is 1, 1, 2. And it gets rearranged into 1, 2, X. And that X, it could be anything. It's probably going to be a 1. This one, 1, 2, 3, X, X. Could be anything here, but probably it's going to be the 2 and the 3, and you just rearranged it. But the problem engine really does look at the array and make sure that it's in this kind of format, that you really didn't remove anything, and that you just rearranged the distinct elements to be the first elements in the array. All right? So I guess the only thing to say about that is, make sure when you get a problem in an interview that you understand exactly what you're being asked to do. And it doesn't help if you're asked to do something like remove all the duplicates when they really don't want you to remove all the duplicates. So there may be some, back and forth on this. I don't know. Yeah. So there's a reason why a lot of people didn't like this problem. Once you understand the problem, it's a two-pointer problem. It's a two-pointer problem, so I know how to do this. Let's use, let's do this. Get a pen. I'm going to copy the array for input 2. All right, input 2 is 1, 2, 2, 3, 3. All right. And the pointers, we have a start pointer on line 4, and the start pointer will be initialized to index 0. The end pointer will also be initialized to index 0. N will be initialized to the size of the list, which is 5. And do a while loop here. We're using end as our iterator. So while end is less than n, we'll take num and set it to end, or a get end. And that is, to start with, it is 1. All right. While end is less than n, which it is, get end equals num. It is, we just got it, and then we increment end. Okay, so increment it, and now it's here. Still in the while loop, end is less than n. Get, is it equal to num? No, it isn't. The reason for this while loop is really just to bypass duplicates. Okay, so 1, 2, no duplicate there. So end, let's see. So we'll drop out of the while loop, and we'll say a set at start, which is index 0, and we'll set it to num, which is 1. Well, it's already 1, so we don't have to do anything, except we do have to increment the start pointer. So start is now here. The start pointer really serves as a pointer of where can we put the next non-duplicate element. Okay, so let's see. We're still in the while loop. While end is less than n, yes, num equals get the element at index, and that num is a2. Okay. N is less than n, get is 2, yes. Increment. So increment is now here. All right. We're going to wind up skipping that. All right, still in the while loop. N less than n, get n equals num. It does. 2 is still equal to 2, and so we increment n again. All that while loop is doing is skipping duplicate elements. Increment again. N less than n, yes. Does get n, which is 3, equal to no? All right, so we'll drop out. We'll set the start index to num, 2. Well, as it turns out, that is already 2. So we can set it and increment start. All right, so now we're going to start overlaying duplicates. Still in the while loop. While end is less than n, yes, num equals get end. All right, so that is now 3. N is less than n, get equals num, yes. Increment goes here. Go back up. End is less than n, yes. Get n, no, yes, it is. 3 equals 3. And so we increment it again. Now we're too far. So end is not less than n anymore. So we got to drop out of the loop. We got to set the index at start to num, and num is 3, and so we'll set that index to 3. All right, still in the while loop, but and we increment start. Okay, it doesn't matter, but we'll increment it. While end is less than n, and it isn't. So we drop out and we return start. Start is 3, index 3, meaning that we have 3 distinct numbers. All right, we've rearranged the list. It's in the correct order. We have 1, 2, 3, x, x, and we're going to return 3. So, okay. The problem description here leaves something to be desired, but it's a 2-pointer problem. So once you recognize that, you should be okay. All right, we're going to get rid of that and try to submit. All right, that's it. Thanks for watching. If you found this helpful in understanding 2-pointers, go ahead and hit like, subscribe, check out the playlist on screen to keep leveling up. The video description and the pinned comment have links to more resources, including a free LeetCode patterns cheat sheet, which you can download immediately. It has the most common LeetCode patterns. And that's it. We'll see you next time.